Welcome to Spring LIB.
31.48. So we have this circuit here, these switches that can be opened and closed. We're told that the EMF amplitude is 12 volts and the driving frequency is 60 hertz. We're told that when both of these are open, the phase angle is 30.9 degrees, where the current leads the EMF. And when S1 is closed, which takes this capacitor out, there's a 15 degrees in the current. The EMF leads the current, or the current lags the EMF. And when they're both closed, we're told that the amplitude of the current is 447 milliamps. And we want to find the values of RC and L, which this has been cleverly contrived to allow us to be able to do. So for part A, when both switches are closed, which removes these components from the circuit more or less, the impedance is just the net reactance of the capacitor and the inductor. So X net equals, and that's our 12 volts divided by our 0.447 amps is equal to 26.85 ohms. Oh, we're not done with that yet. So now if we have switch 1 closed but switch 2 open, this capacitor is still doing nothing. And now we have the same reactance, but it's just now in series with the resistance. And so we have that the resistance is going to be equal to the net reactance divided by the tangent of the phase angle. And we know it's 15 degrees with the EMF leading the current. So this is 26.85 ohms divided by tangent of 18 degrees. And so we discover that the resistor has a value of 100 ohms. Just sort of fence this off. Now for part B, we want to find the value of the capacitor. So for both switches open, we know that X net in the first situation with both switches closed, open. Both switches are open, yes. That this is going to be the resistance times the tangent of the other phase angle. So this is 100 ohms times the tangent of negative 30.9 degrees. The effect that switch 1 has of basically having the capacitance when C is allowed in the circuit, and also so XC is going to be X net that we found before, minus x net in the first situation that we just found. And so the difference between these is 86.81 ohms. Oh, the value of this is negative 59.96 ohms. So the negative sign means that it's just, out of phase enough to be negative. And so we know that C is 1 over omega times the reactance of our capacitor. We just found that. So this is 30.6 microfarads. So now we know the capacitive reactance that goes into our X net. We know that that's equal to the difference between the inductive and the capacitive reactances. So L is XL over omega. XL is just X net plus XC. And so we find that the inductance is 301 millihenries.